Today we have an absolutely fantastic meeting. It's a symposium, that's a one-day symposium, and its topic is the ultrafast vibrational dynamics of biomolecules. And we have really leaders in the field, top speakers, and a large audience. And we now have 2 of the 3 sessions, and it's an absolutely great success. And I'm very pleased. In my lab, I have a number of femtosecond amplifiers, and we specialize in femtosecond spectroscopy of proteins, and particularly ultrafast vibrational spectroscopy. So we measure how proteins move, make tiny movements on ultrafast timescales, and that tells us about reactivity. And with this opening of the lab, we're basically now commissioning state-of-the-art instrumentation that's supported by the college and a number of funding agencies, including ERC, BBSRC, and Royal Society, and it's all coming together right now. And we're using this symposium to basically celebrate this and introduce it to the college.
There's quite a few different experimental apparatus that are all very complementary, and they'll ultimately be used to study light-activated processes. And I think a good example of that is photosynthesis, which has obvious real-world applications, even though we'll be working at the fundamental level. And what we really do is just measure the vibrations of atoms and molecules, and our hope is to sort of understand how something like photosynthesis, again as an example because it's a common one, splits water and converts it to oxygen, which is not a very well understood process at this stage.
I'll be looking at phytochrome, which is a protein that you find in plants and some bacteria, and it's involved in sensing light, and it does a lot of different things. But I'll be looking at the ultrafast dynamics, so how the protein changes shape and different conformations that happens once it's absorbed light.
This facility will be one of the most comprehensive facilities of its type, probably in the world. We're quite specialised in the infrared, which is excellent. And what we've really tried to achieve with this lab, which I think we will ultimately and have in part already, is very, very sensitive measurements where we can measure very small changes down to the sort of 0.00001 level, which is what we're trying to achieve, and in some cases even much better than that.